Hello, 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 and welcome back to another episode of Kerbal Space Programming. Kevin here, and we are finally back to launching various craft into orbit. We spent the last two episodes really mostly talking about vectors and docking and RCS and translations and kind of doing all of this sort of proof of concept stuff, but it is finally time for us to launch new, very wobbly craft up into space. And you can see this is pretty wobbly, but it's also taking we're using our regular good old-fashioned launch script, and you can see that its ascent profile is perhaps not entirely properly tuned. We may have to go back and revise this, but we will be unlocking the larger engines at some point soon, which probably will necessitate coming up with a new launch plan, but we'll cross that bridge when we get to it. But yes, we're finally at the point where we can start constructing our own space station. And so we are sending up right now the kind of core structural element of the space station. And this element does not have really any RCS or monopropellant. It is kind of just a linear thing that we will need to send up other craft to help construct. Because really one of the biggest issues with space stations is trying to make sure that we don't overload it with too many parts, because then it gets very difficult to end up, playing with it in the game. But we can see here, it's got a whole bunch of solar panels, and it is just kind of statically there. It can't maneuver, it can't do anything, and so now we have to send up another craft that can actually help us construct this into what it's supposed to look like. And so here we are with our second launch, and you can see just at the top there, we have a little tugboat. The idea of a tugboat, from regular sailing ships, is that you had very small ships that were much more maneuverable, and they could help large craft kind of pull into dock. I don't know anything about nautical things, but that's kind of the gist. And this is what this is that it is a very, very small craft that has RCS and has various docking ports, and we can use it to attach to the station and pull apart different components and shuffle them around. So with our KSS core that we sent up, oh, by the way, I don't know if I've mentioned that, we're calling this the KSS for obvious reasons. But so we put up the KSS core into a 200 kilometer orbit. This one is just going down into, a regular 70, 80 kilometer orbit. And then we'll have to worry about actually rendezvousing with the core once it is actually circularized. And we'll go ahead and write a script to do that. And then we'll want to go ahead and dock the thing so that it can make its way onto the station. We can start constructing the stuff that we want to. We can see, yep, we are just finishing up our circularization before we can drop away this launch stage. There we go. Okay, some explosion stuff, but let's jump over and start scripting. So I've gone ahead and moved out some of the stuff that we wrote in the previous episode. We had a lot of stuff that was kind of dealing with vectors and all of these various docking maneuvers. I've gone ahead and moved them into a separate file. I'm not going to go through all of these because we spent a long time discussing kind of the strategy for coding all of this in the last episode. But you see, we've just kind of prefixed all of these so that they can live in their own library. I've modified the dock-get port to also get docking ports from a particular ship. We've got things like the approach port and the ensure range and various things. There are a couple of small modifications that I've made. One of them, which was pointed out to me in the comments on the previous video, is that we had this technique where we're going to move to the side of the ship that we're trying to dock with before we move directly out in front of it. That way we make sure that we don't accidentally run through. If we happen to be behind and we run on, we end up running through the ship trying to get to the right position to begin our docking. The problem is that if we are moving to the side, well, what happens if we start on the other side? So I've gone ahead and just added a real quick modification here that will flip the offset if we are closer to one side than the other. So when we're saying, okay, we're going to go to the left or the right, we're going to say, okay, well, if the left is closer, we're going to go to that direction first. And that way we shouldn't run through the ship in an effort to keep our distance. And yeah, we've got kill relative velocity, and then here's kind of the main body of the stuff that we ended up doing in our kind of our fourth test script in the previous video. One small change, and this is something that I noticed when I was doing testing for this video, is that if you are trying to get a particular docking port, and we've got things like, we're grabbing it by the tag name that we've assigned to the port. If the vessel is out of range, if it's more than, I think, 2 kilometers out, then it's unloaded, and when you try and inspect the parts of a ship that is at range, you're not going to actually get any back. So if we were to try and say, let's go ahead and try and keep range on a docking port with this tag name, we may not be able to find that docking port. So instead, this dock function is going to take the docking port tag that we want to control from for our ship, which is one that we can get immediately. It's going to take the name of the target ship, because that we can always get, and then it's going to take the target port tag. We're not actually going to get the target port until we have ensured that we are in range, and that way we know that by the time we're actually making our maneuvers, we're able to get a reference to it, and everything's going to be all right. And then our docking dock script is really just exactly what it had been in the previous episode, that we're killing a relative velocity. Once we've ensured range, we're going to the side of the port, and then we're going to approach the port at 10 meters, 100 meters away, 50 meters away, 20 and 0, and then we should be docked. So this is kind of the general library that we can use for future docking maneuvers. Let's look at the script that we want to have to get our tugboat out to the station. Okay, so here's our tugboat rendezvous script, and we're going to cheat here a little bit because we're really trying to test out this docking. We're trying to build a station. We could start working on writing a library to handle rendezvous, but that's a little overkill. We want to try and keep this simple just for this episode, and we can look at building a robust rendezvous library in the future. So the first thing we're going to do is I'm just going to say, if we have a docking script on board, let's go ahead and delete that, and let's also delete our ascent script just to make sure that we've got space. And we were going to download the docking script that we wrote, and then we're going to run the maneuver library, and we're going to run the docking library. And now I'm going to lock the steering to up. This is something that I discovered. Our tugboat does not have many solar panels, and in previous testing off screen, we ran out of battery because it's really not designed to be its own little satellite. So we were making sure that we're pointing straight up. That way it will always have some sun exposure, at least when Kerbal is not in the way. So once we do that, we're going to call maneuver exec node. Now remember, what this does is it grabs the maneuver node that we can create in the map view, and it will go ahead and warp to it and run it. And then we're going to remove that node. We're going to wait a second, and then we're going to lock the steering again, and then we're going to run the next maneuver node. And so rather than figuring out this rendezvous stuff, we have done a scripted rendezvous in the past, but in this case, we're just going to set two maneuver nodes, one to get out there and one to sort of circularize, and we're just going to let it run it that way, doing our kind of autopilot strategy. Next, we're going to make our initial approach with RCS. We're going to turn on the RCS, we're going to ensure range, and we're going to give it the vessel, and we're going to give it our docking port that we want to control from, and I'm going to tell it to get to a range of 200 meters away at 10 meters a second. Then we're going to say, go ahead and kill relative velocity, and, so we will be roughly stationary relative to that vessel. Now, the reason for that is that the engine that we have that is, propelling us out to rendezvous with KSS has its own docking port, and we need to eventually detach from that before we connect to our own station. So we want to pull this thing out close, but it can't actually dock because we don't have an available docking port. We'll need to undock first. Now, we could undock in the script. Unfortunately, there's a small bug. So normally you can do something like ship docking ports and undock. And we did this in the previous episode. Unfortunately, and I'm not exactly sure what's causing it, this ends up throwing an error at the moment. It does undock, but it crashes the rest of the program. And I've got an issue on GitHub about that. But given that that's having some problems, we'll say we'll just manually undock for this video until I'm able to get that fixed up. So we're going to say wait for manual undock for final docking. We're going to say wait until our ship docking port's length is equal to 2, because at the moment it is 3. It is our propulsion system, and then a small docking port on the front, and then a regular sized docking port on the back. We're going to notify that we're beginning the docking procedure once the docking port has detached, and then we can do this dock library. We'll say dock using the tugboat port as our control port. We're going to dock with the vessel named KSS Core, and we're going to dock to the port called tugboat target. So let's jump over and see how that goes. And here we are, we have our craft and it is ready. There we go. It's beginning its rendezvous procedure. And it should time warp ahead after 5 seconds, just to make sure that it is stably pointed up. And if we switch out to the map view, you can see I've already set up 2 maneuver nodes that are going to get us up to the target. Well, one of them gets us up to the target, and the other one sort of circularizes us around. This is sort of our way of just, one, getting up there and then trying to cancel out our relative velocity. Of course, we're not accurately canceling out relative velocity, but it's going to get us within the realm of the same speed as the ship once we get up there, and then we'll just have to rely on the RCS to take us the rest of the way. Now, because we're only going to be approaching at 10 meters per second, it shouldn't require a ton of RCS for us, especially since this is a very light craft. It will, however, mean that it could take a significant amount of time. And in fact, it's true with the ISS that prior to, I believe, 2008, actually getting to the ISS was a 2-day maneuver that they'd have kind of their initial launch into space and they'd end up in an orbit, and then they'd have to make a series of various burns before they'd actually be able to rendezvous, despite the fact that the ISS actually orbits very, very near to the Earth. It's in a very low orbit. Now, of course, there's a enhanced Soyuz mechanism for doing that gets them there in about 6 hours. All right, we're time warping, and we can see there is our target. It is up there, and it's still fairly far away, and you can look on the nav ball, and you can see that our maneuver is not exactly, yeah, if we target that, there we go, yeah. You can see that we're not exactly going to be killing out at relative velocity. We're a little bit off, but for kind of just eyeballing, setting up some maneuvers, this really isn't too bad. I've also gone ahead and, on the KSS core, I've gone ahead and collapsed in those solar panels just to make sure that we don't collide with anything when we start approaching those docking ports. But there we go, we are canceling out our relative velocity, and come on, get there, and as soon as it's done, it should kill the node. There we go, okay, it's done. And now it is time for us to make our initial approach, and you can see it is firing up, it is killing out the relative velocity. I believe at the moment we're moving away from the station, so we're having to kill out about 200 meters per second and then add an additional 10 because we want to be approaching at roughly that speed. And then once we get to that 10 meter per second approach, the RCS shouldn't really have to fire other than to do some very minor corrections as we get in closer to the station itself. And you can see now we are approaching, and we are pointed vertically, by the way. During our get to range, we're pointed at the sun, but if we look at the map view, we can see that there's where our nearest approach is, and it is something like 5-6 minutes away, and even then the separation is more than it will eventually be. The RCS will very, very slowly make these minor corrections over time, and you can just see in the nav ball that our current velocity, our prograde vector, and the target's direction vector are equal. And now I've actually gone ahead and switched us into 8 times time acceleration, so we're going at 8 times the actual playthrough speed, because this ends up taking a ridiculously long amount of time. I mean, if you think about, we are approaching by 10 meters every second, and we're trying to cover a distance of, you know, what is it, 7 kilometers was our starting distance, so that's what, 700 seconds, which we divide by 6, so that's a little over 10 minutes of game time just going ahead and maneuvering this. Now, a lot of times when you're doing when you're flying manual missions, you may go ahead and just use the engines to get yourself relatively close and then try and cancel things out, but realistically, we're using almost no fuel to do this. Even though it is monopropellant, we're using very, very little, because once we have our 10 meters per second approach vector, it is pretty much stable, and it requires only just the tiniest twinges of monopropellant. You can even see, you know, we've got so much of it left in our resource tab, and there's just it's every so often flipping between using 0 and using 0.1 monopropellant as it makes those final corrections. But over time, over a very, very long period of time, we're starting to bring ourselves in close, and we can finally actually watch the numbers tick down. And I think we're just about ready to drop out of 8 times time acceleration, because man, oh man, yeah, you did not want to have to sit through all that, and I certainly couldn't come up with enough interesting things to say over that period of time. It's been a challenge in particular to keep these videos around the 20-minute mark. I usually end up more around 25, and even that is cut down from an hour and a half of footage generally. But yes, we're making our final approach, and we're trying to get to that 200-meter distance, which is where we're going to park the actual drive section that got us, that got us our initial rendezvous, and then we can go ahead and split and run the actual docking. So you see, we've actually closed a little bit, and now it should be just trying to cancel out the velocity, so that once we do detach ourselves, we should be perfectly safe to kind of leave that thing floating around and, it's not going to fly too far off. Hopefully we'll be able to go and recover it and eventually attach that to the station. And then eventually maybe, chuck it back into the atmosphere and let that burn up, because we don't want to be space litterers. And yet we can see now it is very, very close to canceling out. And no, I think it's trying to keep us at the right range. Okay, there we go. It says we were waiting for manual undock, so unfortunately we can't do the docking the traditional way, but we'll go ahead and decouple this node here, and then it detects that immediately. It says, all right, I'm going to begin the docking procedure, and now it's going to approach the 100 meter range mark according to the scripts that we developed in the previous 2 episodes with our test docker craft. And we're closing in. You can see I really love the distant object enhancements mod, in that we can see this stuff despite having, a fair amount of distance. And now, yep, it's doing all the same stuff that we kind of manually did at the 200. It's trying to cancel out the relative velocity. And now it is trying to do a sideswipe maneuver, I think, though it's a little bit close to the station. That's probably closer than I would have expected. We may have to look back and see exactly what it is doing there. But all right, we're heading up on top, and you can see that this tug should be really, really helpful. It's got just a small docking port, which we'll eventually use to keep it attached to the station. Then it's got the main docking port on the bottom of it, which it can use to pull around various parts of the station. This is kind of our version of the Canada arm that they have on the ISS. Now, there is the Infernal Robotics mod, which you could also, I guess, potentially use to actually do a regular Canada arm type of thing. And yeah, unfortunately, you see me fighting with the camera trying to get a relatively decent view of this docking, because it just didn't want to let me zoom around. But we're coming in now on our final approach. You can watch the speed, and you can see, look at that alignment. Our target and our prograde vector are right in line. Though, of course, they will diverge a little bit because we're targeting the craft and not the port. I probably should have switched that. But we can see that we have gone from launching 2 independent vessels, and hopefully they're going to go ahead and dock in space, all automated, except for us going ahead and undocking and setting up those 2 maneuver nodes. And obviously, once we have a lot more station traffic, we'll want to create sort of an automated rendezvous script that can handle that as well. But we're getting in close, and there we go. It zooms out. That means we are attached. Wonderful. And now we have this thing on the edge of our station, looking weird, rotating around like crazy. But we also did get a world first milestone. We got a little bit of science. We have started to begin a station. Somehow KSP knows that. Now let's go ahead and think about how we can start doing some construction. So the station was really designed with the idea that we would be able to launch this all under a fairing. And so this top part is not designed to be where it is. So I'm going to go ahead and we're going to add change the name tag. I could have done this in the vehicle assembly building, but yeah, I wasn't thinking ahead. So we're going to call this tower port. There we go. We'll click accept. And I want to change this, and I'm going to call that top port, and we will hit accept. And now we also have to be a little bit careful because we have 2 cores on this station, and our boot script is a little bit tricky when it comes to that. But really what we want to do is we want to maneuver this to the top. So let's go ahead and decouple. Nope. I can't remember what I was doing. Right, okay, so we've got the 2 cores. We're going to disable this core first. That way we know that it's not going to end up accidentally intercepting any commands, because we want our tugboat to be the core that is actually running stuff. We may want to update our boot script eventually to handle that sort of thing. But now we're going to go ahead and we're just going to let this thing go off into space. And it doesn't have any sort of drive section. If we switch to it now, we can actually rename this craft. That way we can refer to it later, and we can dock the core of the station back up with this. So we're going to call it KSS Tower, and now we can switch over back to scripting world and write a script to go and get this little thing back. Alrighty, so now since we don't have to do rendezvous, and we're not trying to get into range, we're not trying to pull stuff along with us, we can do this pretty darn easily. We're just going to run our docking library. We're going to notify that we are initiating our redocking maneuver. We're going to say dock using the top port, as the control port, and we're going to dock with the ship named KSS Tower, and we want to dock with the port named Tower Port. So let's upload this and see how that goes. And now here we are in 4 times acceleration because, man, this maneuver ended up taking a ridiculously long amount of time. And unfortunately, because we are dragging around a relatively large craft at this point, we've got a little bit of... there's a little bit of an issue with monopropellant because, yeah, this thing is a lot heavier than the tiny little thing that we were tugging around before. And in particular, the safety maneuvers that we have of getting to an appropriate range and then getting to the side of the thing, and especially since we're trying to get to that range at a speed of 10, and it's very difficult to change, to slow ourselves down, I think that it ends up kind of oscillating back and forth. It gets to 105 and then it goes up, I've overshot, and then it goes to 95 and it goes back and forth. And because we're not able to speed up and slow down as fast because we're more massive, it ends up wobbling quite a bit, and you see we are just hemorrhaging monopropellant, which is not optimal. We probably want to only use our kind of do everything script in cases where we're doing kind of regular docking with something that is equipped for it, rather than trying to maneuver around this bulk of a station, because, yeah, or at the very least, if we had taken the speed down, there'd have been less oscillation, and it would have detected, okay, good, I'm at the 100 range, or whatever. Of course, there's no reason that we have to stay 100 meters away from this tiny little thing, but the idea with the script is that we would use it kind of as a generalized case. But yep, you see, it's just bouncing back and forth, trying to get to the point where it is both pointed in the right direction and at the right distance, and almost out of monopropellant in the process. But now we're back down to regular speed. And we're bringing this thing in. One thing we also haven't considered is the actual rotation of these docking ports. That's something that we may want to add in at a future point in time. But there we go. All right, we have our station, and now we can see, sort of, to if I can get the camera to. The camera's not being great. All right, let's just make sure. I'm going to go ahead and cheat here. I'm going to turn on the panels and the lights so that we can see kind of what the station is actually supposed to look like. Of course, that fuel tank will eventually be discarded, but our station, we've got lights in the docking ports. Those 2 side docking ports are for visiting vessels, and our station is supposed to look something like, if I can just, I need to rotate it, there we go. Our station is supposed to look like this, where we have this control tower at the top. The tugboat will eventually move out of the way, and we'll have a longer habitation section at the bottom, and then we'll have those 2 docking ports on the side, where visiting vessels can come and join in all of the fun. And wow, it took a lot of scripting for us to get to the point where we were able to do reasonable docking, and still we could make some tweaks to make the monopropellant use a little more efficient. But this is very, very exciting. We'll build on to our station with future stuff, though of course I think we may need to send up some refueling monopropellant in the near future. So I will hope to see you in the next episode, and I will talk to you then. Cheers.